7, 10, 12, 13, 16. Put it in your pocket.
It is my
no,
pocket.
that pocket. All right. Let's do questions about your house. Leo, the whole class is welcome. All right, everybody said, hey, you might not can hear them, but they're saying hey. Any questions about your homework? Not everything. You said everything? It was hard? It was like, Red said it was light work. Okay, number 8. So I think that if you struggled, it might be because there's multiple ways that we can go about simplifying these. It's not just one strict way. Okay. Can I do this one first? Okay. All right. I'm going to go through this a little bit more convoluted way, but would y'all quit fighting? I feel like I'm at home with my children. Okay. Oh, she told me she's sorry. She said it's past. She's fussing. I'd rather stay at school. Okay. So here's what I'm going to do. This way's a little bit longer, but it's the way that you can always do it. I'm gonna, before I simplify anything, I'm just gonna go ahead and do root 14, and I'm gonna get that radical out of the bottom. Is that what y'all did? Okay. All right, somebody with a calculator. Is 8 times 14? Now I'm going to try to simplify the 112. I said try to simplify the 112. I know I can divide it by 4. But I can do something bigger than 4. Let's see. 16. 112, I could do 16 and 7. Right? So I get 4 root 7 over 28. But now, that's okay. But now the question is, how do I simplify this? So do I simplify the 7 and 28 or the 4 and 28? Why? Why can't I do the 7 and 28? Because the 7's under a radical. I can't simplify that way being under the radical, so I have to simplify. Yes? So say yes, because that's right. Okay. So square root of 7, 4 divided by 28, 7 on the bottom. Does that become 1? No. Does it become square root of 1? No, you can't simplify them, even though it looks like you can. You can't. No. Give me another one. 9. 4. 4's got a lot of parts to it. That might be part of the problem. 225x 22. Now for this one, I probably would simplify. The only reason I say simplify this one before you start is I noticed this is a square root and this is a perfect square. That's the first thing I saw whenever I wrote this. So square root of 225 is what? 15. So you got 24 times 15, and then 2 goes into 22 how many times? 11. Remember, if I've got it under the radical and it's a variable, I say 2 goes into 22 how many times, and whatever's left stays under there. So I got, what is it, 360 x 11 over, and I can actually do the same thing with this x4. Okay, it's not wrong to multiply the top and the bottom by root 5x4, but the square root of x to the 4th is x squared. So I could really write this as 4x squared square root of 5. Does that make sense? Sometimes it's easier to clean it up first before you simplify, before you rationalize. Just because multiplying by square root of 5 is a lot easier than multiplying by square root of 5x4. Does that make sense? All right, I'm still not done because I have to rationalize here, right? All right, and actually, I might simplify this before I rationalize. What does that become? So I've got, and how about 360 divided by 4? So I got 90x 9 over square root of 5. Yes? Now I can multiply by square root of 5 top and bottom. So I end up with 90x 9 root 5 over 5. Can I do anything else? Yeah, what? 90 divided by 5 is what? Maybe you went about it a different way. Oh, yeah. We got 6 up top. Yeah. Number 7. So I'm going to split this up. I'm going to do root 3 because 3 doesn't divide by 20 evenly, right? Armando, who's your friend beside you? What the heck? What are you doing? Who are you talking to? Yeah, she can go to the bathroom. That's brilliant today. 3 over 20 does not reduce to anything, yes? So I leave it. I could break this one up. Did y'all break this one up before you started? No, you just left it square 20. That's fine. We'll leave it. See what happens. I would have broken it up, but you don't have to. 5 and 4. You got 2 root 5. What happens is I end up with the square root of 60 over 20. And now I can break 60 down. What and what? I got you. 4 and 15. So I get 2 root 15 over 20, which becomes what? 2 divided by 20 is 1 over 10. That's right. So root 15 over, ooh, we're going to have to practice with these. I can do that. Yeah. He said, are you sure you're logged into your school email, Peyton? At home. Down the 400 hallway. Know where that is? Yeah, across from Mr. You want to take him? Osmond will take you. Osmond loves to walk. All right, what else from your homework? Yeah. You ready? You understand this? Okay. How about anything else from your homework while we're here? All right, so after I show you what I got to show you today, because today is pretty easy, I got you some practice with this also on the back so we can get in a little more of that. But let's switch gears. Huh? I can't tell you. No. Oh my gosh. I got two minutes. I'm on diet. All right, I'm going to tell you what sunshine is. Okay. When we have a radical, let's say something like this. Okay, I call this radical, or we call this radical form. We can also write this as an exponent. Every radical can be written as an exponent. I call this sunshine problem because this is so stupid. I had a foreign exchange student one year a long time ago, and it has stuck in my head, and it is the stupidest thing, but it's so stupid that it just sticks in your head and you remember it. And he said, oh, we did this in wherever he was from, Peru or something, I can't remember. Anyway, and he said, oh. Anyway, he said, we call these sunshine problems. And I said, what in the world does that mean? And so he came up and he showed us, and this is what he said. When you switch from radical form to what we call rational exponent form. I'm even putting it in yellow so it looks like a sunshine. Yeah, he said when you do this, he actually drew this picture. He said, think about a sunshine. So if the sun is shining down, and it should be up at the top now. Shining down. Okay, put your sunshine wherever you want. All right, so when the sun is beating down on my radical form, no, we don't do solar eclipses in here. All right, in this form, the 2 is in the shade, and the 3 is outside getting sun, yes? When we change the form, the base stays the same, so it's x, and then we make a fraction out of these two numbers. This time the 2 goes up top and gets all the sun, the 3 goes on the bottom in the shade. So if he's getting all the sun in this form, whoa, if he's getting all the sun in this form, then he has to be in the shade. That's all it is, the changing forms. You will never remember. It gets confusing on which one's on top and which one's on bottom. We're not failing. Yeah. You paid for what? For what? I'll help you. Okay. Ready? Let's switch some forms up here. If I started out with 5/2, write that in radical form. What's it look like in radical form? Oh. I don't have to put the 2 out there, but if you want to put the 2 for the root, you can. It is implied. Now, I will say, and this is where things get a little bit confusing too, is I could also write this way. And it's the same thing. Yeah, this is what sunshine means, going from one form to the other. All right, let's see if we can work a few. Not quite yet. We will, but not yet. Write it in exponential form. Write it in exponential form. To the 1/4. Yep. Make sure you put the 8W in parentheses. Yep. Yep. Because remember that property of radicals that we learned, we could really write this way. So we have to make sure that that exponent goes to both of them as well. Yeah, that's how we split them up, when we split them up. All right, let's do this. I want you to simplify. I want you to rewrite it in exponential and then simplify. Or if you want to simplify, write in exponential and then, but I want your final answer in exponential simplify. Remember, simplifying exponential means I'm breaking it up. You might have. Tell me what you think you do first. What, as I look at this, I'm going, what in the world am I supposed to do, right? So if I simplify first, what do you do? If you're multiplying with the same base, what do you do with the exponent? Add them. That's exactly right. So how in the world do I add a 4th and 3/2? Well, I'm probably doing that on my calculator, not me. But if you like to do things by hand, and hit math, enter. That's exactly right. That is exactly right. But remember I said to simplify. Is that simplified? There you go. 4 goes into 7 how many times? 1. And how many is left? So my simplified radical here would be P. Yeah. Mm-hmm. Rhett, put your phone up. Go put it up. You're gonna write it down. You did what? 4 goes into 7 one time, and then there's 3 left. Because I took out. Yep. What? It's got to be the same base, but combined. Mm-hmm. Dennis, yeah. Rational exponent. Yeah, you want your assignment? It's not much harder yet. Try this one. I'm going to start this one in exponential form, not in radical form. Golly, I had a brain fart. In radical form. That's right. Thank you, Armando. I'm going to start these going around if you are good. Simplify. So simplify and make sure your final answer is in radical form. Simplified radical form. That's always a good thing to do. I always tell students, if you ever get confused and you just don't know what to do or which direction to take the problem, try changing the form. And sometimes the answer just pops out to you when you change that form. Before I simplified, I got r to the 5 over 4. Is that what y'all got? Good. Okay. Huh? Yes, and then simplify. So put it back in the radical, and then how many times does it go in and what is left? You can. You've got plenty of time. How about this one? If you don't need any more practice and you got it, feel free to jump ahead to your homework. I know a couple people look like they're still struggling a little bit, so I'll do a couple more examples with you. You help me? Thank you. Yeah, go ahead. Yes. I would actually, before multiplying this, I would change the forms here. I'd say this is 7 to the 3 over 2 over 7 to the 1/2. Because I'm dividing, I can subtract here, right? 3 over 2 minus 1 over 2, which would be you're not wrong if you multiplied by square root of 7 top and bottom. You wouldn't be wrong at all. Just, let me show you what happens. Yeah, I do. Okay, Armando, happy to help. You don't want me to show you what happens? Okay. Multiply top and bottom by square root of 7, right? We'll multiply the top and bottom by square root. That's what you said to do, right? All right, so I'm going to combine these two. 7 to the 3rd times 7 is what? So I got the square root of 7 to the 4th over 7. 7 to the 4th, right? And 4 divided by 2 is 2. You've got 2 7s up top and 1 7 on the bottom. So I get the same answer. It doesn't matter which way you do it. Do whatever you want. This took a little bit longer to get there. Okay. Anybody else need any more? Or y'all want to start? You want another one? Let's do how about 16 to the 2/3 times 16 to the negative 1/3? What can you do? What do you think you do first? See how the bases are the same? Since the bases are the same and I'm multiplying, I'm just going to add those exponents together. So what is 2/3 plus negative 1/3? Right? Now I'm going to put it back as a radical. So that's the 3rd root, because this number is the root, of 16 to the 1st power. So now I want to see if I can break it up in. Is there a perfect cube you can divide 16 by? Which one? Perfect square, so go cube, but you're right. 16 is a perfect square. We're talking about cubes, so to the third power. So this would be 8 and 2, so it would be 2 and cube root of